Hey guys, how's it going? So the point today of this video is to show you an example of what it's going to look like when you see parametric problems on an AP test. This is something that shows up a lot, both in the multiple choice and the FRQs. And usually when it's on the FRQs, and that's kind of the focus today, it's usually a problem where you're going to be given some combination of dx dt and dy dt. Like they'll give you the first derivative, like in the example I'm about to give. This is something that is also usually a calculator problem. Occasionally it'll show up on the other one. Or on the no calculator section, but usually be allowed to use a calculator on these problems. And it's something you can expect pretty much every other year. Every year or two, you'll get a parametric problem. So it's something that's very common. You should be expecting it. And actually, these problems aren't too bad, so you should be excited to see an FRQ about these. Some of the things they might ask you to find, they might ask you to find a speed or a distance traveled. We just talked about those in the last one. Or they might ask you to find, an acceleration or a position. We're going to talk about that today. Something like a slope of a tangent line. Those are all reasonable things that they might ask you about. So make sure that you know how to do each of those for your tests on this chapter and then for the AP test. So let's get to some example. This is going to be a multi-part problem. They give you a dx dt is cosine e to t, dy dt is 6t squared plus 1. And I'll ask you in part A, and again, this is some object moving, and this is the velocity in the x direction and the velocity in the y direction. So in part A, I'm just going to ask, is the object moving up or down at t equals 2? Is the object moving up or down at t equals 2? Okay, well, how do we find if it's moving up or down? Well, if it's moving up or down, that has to do with a vertical movement, so that would be in terms of y. So what this question is basically asking is dy dt positive or negative? So, okay, first off, let's find dy dt, right? So dy dt at time 2 is equal to 6 times 2 squared plus 1, which is 25. Again, the value here is not super important. What's important is the sign. So since the dy dt is actually a positive number, that means that y is increasing, which means that this object is moving up. Okay, so that's how you approach a problem like this. Part B of this hypothetical problem here, and I think there will be like 5 or 6 parts here. Part B, I might say find the speed at t equals 2. Okay, we want to make sure we know the speed equation. That was inside the total distance traveled equation. So that was just the square root of the dx dt squared plus the dy dt squared. So when you plug in the t equals 2, let's see, we'll plug in 2 there. So that is square root of cosine of e squared, and plug in the dy dt, that's just 6t squared plus 1. So actually we just found that plus 25 squared. Okay, so that's how you'd find the speed. I mean, you could get a decimal, of course, and you need it from multiple choice, but this is fine too. All right, now part C of this problem, let's say I ask you to find, well, if I ask for like total distance traveled, then we just integrate this. But let's do another one. Let's say we ask you to find the acceleration vector at t equals 2. Okay, now acceleration we know is the derivative of velocity. And the vector part keys us in that there are 2 parts. We need to find the x part and the y part. So we need to find what x double prime of 2 is equal to, and we need to find what y double prime of 2 is equal to. Okay, now if x prime is equal to cosine of e to the t, remember, something like this you should just do on your calculator. It'll be really simple. So you'll just go over here, you'll say, all right, I'm going to take a math 8, I'm going to take the derivative of cosine of e to the power of x, close, 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 and then I take the derivative with respect to x at the value of 8, and by 8 I mean 2. And that'll give me, okay, negative 6.60469. Nice. Okay. And then for your y double prime of 2, that's something honestly that's like so easy to do by hand, right? Y double prime, if your y prime is 6t squared plus 1, that's just 12t. So my y double prime of 2 is equal to 24. Now, you can leave your answer like this. If you want to like combine these into a single vector, you can also write it as negative 6.60469, comma 24. Okay, and again, this would be accepted, this would be accepted as well. All right, so that's acceleration. Next thing in this problem that we're going to do, and we have not talked about this before, is position. But the strategy of this, of course, is going to be very similar. position. Okay, so let's say I tell you at t equals 0, the position is 1 comma negative 1. And then I'm going to ask you to find the position at t equals 2. All right, well, when they tell you the 1, negative 1, they're basically saying this is my position in terms of x at time 0. This is my position x y, sorry, at time 0. And when we find a position at time 2, you need to do this separately. You need to find x of 2, and then you need to find y of 2. Now, if we had a dx dt and we had an initial condition, don't we have a fundamental theorem we could use to find x of 2? Yeah! So, again, the key in here is we're going to use the FTC. We have this initial condition, the x of 0, y of 0. We have the derivatives here, the dx dt and the dy dt. So if I want to find, say, y of 2, okay, y of 2 minus y of 0 is just integral 0 to 2 of the dy dt. So that's saying that y of 2 minus, okay, the initial position is negative 1, so plus 1, equals integral 0 to 2. Dy dt is what? 6t squared plus 1. Great. 6t squared plus 1. Okay, so then I'll just subtract a negative 1 to both sides. So y of 2 is negative 1 plus integral 0 to 2 of 6t squared plus 1 dt. Now, I'm feeling incredibly lazy, and my free trial is about to expire. So I need to go ahead, or I don't need to, but I'm just going to go ahead and plug this in my calculator. So negative 1 plus, and then I'll go ahead and do the integral of 6x squared plus 1 comma x comma 0 comma 2. Okay, and then of course that'll just give me my lucky number. Y of 2 is 17. Okay, and then the way I'll find the x position is the same. Again, it's a position I need to find x and y separately. I know x of 0 is 1, so I'm just going to say x of 2 minus x of 0 is integral 0 to 2 of the dx dt. So that's like the integral 0 to 2 of cosine of e to the t. And then again, my x of 0, they told me is 1. So I'll just plug this in my calculator. So I'll do 1 plus, and then I'll do math 9 to bring up the integral. I'm integrating the cosine of e to the power of x, close the e, close the cosine, and then the x goes from 0 to 2. Okay, and that should give me an integral there of x of 2 is equal to 0.7722. All right, so that is my position. There's my x and there's my y. Again, the key is to use the fundamental theorem. They'll always give you a point to start with on these problems. I'll do a little sanity check. Yeah, I'm still in radian mode. Good to see. Okay, so that's how I'll approach that. Next thing I wanted to talk about was a displacement problem. So you'll see a problem like this. So find, I don't know why I wrote 4, she wrote part E. Okay, so part E, a problem might ask you to find the displacement vector, and again, using the same dx dt and dy dt, find the displacement vector from, let's say, t equals 0 to t equals 4. Okay. And remember that when we see the word displacement vector, that's a change in position. So what they're asking me for is like how much did the x change, and then how much did the y change. And if I want to see like how much the x changes and how much the y changes, that's just like the integral 0 to 4 of dx dt. And that's the integral 0 to 4 of dy dt. So that's all it's saying. It's just our change in our horizontal position and a change in our vertical position. Again, let's just go ahead and go straight to the calculator here. We'll take the integral of 6x squared plus 1 going from 0 to 4. And I'm showing exactly as much work as you'll need to on your test and whatever. You just write out the integral, like I said, and then you can jump straight to the answer. I'll do the same thing. I'll just bring this up again and see if I can get cute and just change this. So I'm doing cosine. Oh, no, I screwed up. That's all right. Math 9, and then cosine of e to the power of x. Oh, it's going to be perfect. Close, close. And then that should give me my x coordinate. Okay, so what that means, the way you can interpret this, is that like over this period in time, we moved 0.354 spots to the left from 0 to 4, and we moved 132 units up in the positive y direction. So that just gives you like how far did you move right and left, how far did you move up and down. And that's what a displacement vector kind of says. Okay, the last part of this problem that I wanted to share with you, part F, is find the time t on 0, 1 when the particle's slope is 4. So I want to take this particle slope is 4 and turn this into an equation. Okay, so if my slope is equal to 4, how do we kind of qualify slope? Well, slope is just dy dx. So that's saying that dy dx is equal to 4. Okay, so what that's saying is that's saying that my dy dt over my dx dt is equal to 4. All right, so let's plug those equations in. I'm pretty sure I still have 6t squared plus 1. Okay, so that's saying that 6t squared plus 1 divided by cosine of e to the t is equal to 4. Okay, now this is an equation that of course is very difficult to solve by hand. So what you're going to need to do is use this on your calculator. And don't forget that when you use your calculator to solve, you want to graph both of these. This is your y1 and this is your y2. The key tip that I want to give you is when you use your calculator to solve an equation, you want to make sure that you are in function mode, not parametric or some other weird mode. You'll find there's actually no second calc intersecting parametric, so you have to be in function mode. So what I'm going to do, again, is I will graph both sides of this equation. I'm going to graph the first side as y1, I'm going to graph the second side as y2, and try and see where do they intersect each other. Okay, so let's do that. So I'm going to graph here, oopsie. So I'm saying where does the slope equal 4? So I'm going to graph parentheses, 6x squared plus 1 divided by cosine of e to the power of x. Okay, close the e to the x, close cosine. Cool. And then I'm trying to see where that's equal to 4. One more thing I want to talk about is when they say that the time is on 0 to 1, they're kind of saying like this is the window you want to use. You want to look between the x values from 0 to 1 to try and see where that happens. Okay, so I'm going to change my x values so it goes from 0 to 1. I'll graph this. All right, well, the y values are terrible, so let's go back to like some normal ones there. We'll go to -10 to 10, and we're going to try and see where does that slope equal 1. All right, and we see that one value right around there. Okay, so I'm going to go to second calc intersect. Okay, so I'll go over here, and I don't know what's going on here. All right, so we're going to find enter, guess. Okay, and that's the intersection point, and that's the time value. So notice I type this in terms of x instead of t, but it's the same thing. So the time when they intersect is 0.218. Making sure I'm writing at least 3 decimals. And that's the work that you have. You set up your equation. Okay, where does the slope equal 4? I plugged in my slope, my dy dt over dx dt, and then I use my calculator to solve that by finding the intersection points. That's generally the easiest way to solve it. Okay, so thanks for watching, guys. That's what AP problems are going to look like on the AP test about parametrics, and that's what you can kind of expect to see on your review and your test. All right, thanks for watching. Bring your questions to class. I'll see you soon.